Here in this video, we are talking about an apparent change in the frequency due to the relative motion of source and observer. That is called Doppler effect definition itself. There is a relative motion of source and observer. There is a change in frequency, apparent change in the frequency. That is called Doppler effect. In the previous videos, we have done two cases. When the source is in the state of motion and observer is in the state of rest, we have derived expression for the apparent change in the frequency as n dash is equal to n of v by v minus vn when the source is approaching. When the source is moving away from the observer, in the place of this minus, you will be getting a plus. So you can write a general equation as apparent change in the frequency is v by v plus or minus vs into n. That is when source is in motion. So you could have noticed the term that is affected is denominator here. Numerator is the same. If you consider observer is in motion, the derivation also we have made in the other video, in the previous video. Please look into that. If the source is in the state of rest, observer is approaching, we have derived equation for n dash as v plus vo by v into n. And we have also derived that if the observer is going away, in the place of this plus, I will get a minus. So the general equation n dash is v plus or minus vo by v into n. That's when observer is in the state of motion. So what you can notice is when source is in motion, you see the effect in the denominator. When observer is in motion, you see the effect in numerator of the equation. Now we would like to derive a case when both are in the state of motion. When both observer and source are in motion. Let us write a possible equation for that. Imagine source is moving towards the observer. Observer is also moving towards the source. Let's consider first what happens when the source is approaching the observer. As I told you earlier, here source is approaching. So the equation that we have written is in the denominator v minus vs of n, like I have written earlier. Now let's go to the other part. When the observer is approaching, come to that part. When the observer is approaching, we have written an equation as v plus vo. So in the numerator, I have to write v plus vo is the apparent frequency n dash. So I have just combined the first case and the second case to get this new third case. When the source and observer are moving towards each other. I want you to observe one thing little carefully. Whenever a source is approaching the observer, apparent frequency n dash, I'll write the equation. Source approaching the observer in the rest, n dash is v by v minus vs into n. This n dash is greater than that of n. For that to happen, denominator has to be less than the numerator. Numerator is having only velocity of the sound. That's why denominator shall have v minus vs. Then only denominator can be less than that of v. Right? Let me tell you other case. If source is going away from the observer in the state of rest, and dash is numerator is v only, as you know, as we have derived. In the denominator, the question is you have to write either v plus vs or v minus vs. As the source is going away, apparent frequency is less, we know. As the apparent frequency is less, denominator has to be more. V plus Vs into N. This is the case like you are waiting in a railway station for a train. When the train is coming towards you, that is in this case, you feel the horn of the train appears like increasing. And when the train is going away from the station like this, your observer who is waiting for the train in that on the platform, you can notice that the frequency of that sound appears like decreasing. That can be simply explained basing on this. So you can see whenever a source is approaching, denominator will have a minus. Whenever a source is going away, observer, a denominator will have a plus in the equation. The same is the case with this observer in the state of motion. Like imagine a source is in the state of rest. You are an observer coming towards a train. So you can notice as you are coming towards the train, sound appears like increasing. So V plus VO by V into N. So whenever a source is approaching, in the numerator you shall write a plus. Similarly, whenever observer is going away, you know that here N dash is greater than N. Here N dash as you are going away will be less than that of N. For that to happen, numerator has to be less than the denominator. Denominator is fixed. In this case, when observer is in motion, denominator is V. When numerator is in motion, numerator is V. V is the velocity of sound. So the numerator has to be less. So V minus VO comes into the picture. So if you once notice that basic aspects, writing equations becomes very easy for you. Let us write some more possible cases, right? Yeah. This is when what I have written when both are approaching. Now let us write a case when both are moving away from each other. When both moving away. What I mean by that, source is going away from you. You are also going away from the source, observer, right? So what is N dash? I have to write. We shall remember that denominator will have a source effect, numerator will have a observer effect. Let's come to the denominator. As the source is going away, apparent frequency has to be reduced. If the total apparent frequency has to be reduced, denominator has to be more so that the fraction value will be less. So it has to be V plus Vs. Let's come to the numerator. As the observer is also going away, apparent frequency has to be less. But observer term is in numerator. For that, to have a lesser value, as observer is going away, frequency has to be less apparent frequency. To have a lesser value, numerator shall reduce. So we shall have V minus VO of N. Like that, by understanding the basic logic that when source is approaching or observer is approaching, frequency increases. When source is going away or observer is going away, frequency decreases. By understanding that basic logic, we can write any equation of the Doppler effect. Let us consider a case like, um, let us say, observer is going like this, source is going like this. So observer is changing a source. In that case, you can write an equation N dash as, see the source. Source is moving away, so apparent frequency decreases. That is in denominator. So decreases means denominator has to be more, V plus Vs. Look at the observer. Observer is approaching, so apparent frequency increases because of the observer motion. If it has to increase, it has to be plus in numerator of N. Like that, for any of the case, you can write a Doppler effect. Once if you understand the basic observation, that what is that basic observation is? Observation. If you write a general equation N dash equal to V plus R minus VO by V plus R minus Vs into N. The first thing that we have observed is observer effect seen in numerator. Then, well, source effect seen in denominator of the given equation. When observer is approaching, either observer or source, approaching means n dash will be increasing. When they are receding or going away means n dash is decreasing. Basing on that, you can write any of the general equations of Doppler effect. Please write different cases. If you have any concern, you can comment there, right? Thank you for watching.